Hi, this is Ron Boring, and I'm here in Phoenix, Arizona with two of my friends, Tom Ulrich and Roger Liu from the University of Idaho, and they're going to tell us about an experiment they're working on.
So just to give you some quick background, this is Tom Ulrich's dissertation research, which is what he's doing to get his doctorate degree at the University of Idaho. He's going to be talking about the microworld experiment, and a microworld is simply a process control system, which is like a simplified simulator of a nuclear power plant. And the goal here is to train students to operate that simulated plant. The design is really, he's measuring attention and expertise, and this could be broken down into a 2x2 design, where you're looking at eye tracking versus attention markers, and student operators versus professional operators. In case you're not familiar with eye tracking, in eye tracking you're tracking someone's gaze using special glasses to see where they're looking. Some of the cons are that the equipment is relatively expensive, although it's becoming less expensive over time, but it's also typically very time consuming to analyze. In terms of attention markers, this is something new that Tom has created. They look like screw heads on the screen that turn randomly, and the participants will click when they see them moving. They tend to click only on those where they are paying attention. So some of the pros of this is that it can easily be embedded in the simulator since we created it, and those clicks can be automatically logged and analyzed. So we're looking at something that may be less expensive to implement and take less time. Tom's research question is, do the attention markers offer low-cost, easy alternative to eye tracking? Here's a picture of their simulator.
Now, your study involves something called a microworld. Could you explain what that is?
So the idea with the microworld is that we want to know how to make interfaces better for operators in real-world settings. But the problem is that finding operators for these types of studies is expensive, and it's hard to actually get their time. So by developing what we call microworlds, or gamified versions of these control processes that are simple so that regular students can be used as participants, we can explore concepts with the microworlds and then apply them in real-world settings.
So Roger, you said operators. What do you mean by operators?
Good question. So an operator is a trained professional who works in a control room to control the process. A microworld is kind of like a control room.
Thank you, Roger. So Tom, what exactly are you doing in this study?
Okay, so this study is a methodological study which aims to compare an existing eye tracking measure that tracks where people are paying attention based off of where they're looking, and this is being compared against a new measure which uses tiny little events and how people acknowledge or fail to acknowledge those events in order for us to track where they're paying attention. So it's a different form of measuring where people are paying attention in a simple way.
So Tom, you mentioned eye tracking. What exactly is eye tracking?
Good question. So eye tracking uses a camera to track where the eye is pointing, as well as where your head's positioned in a lot of cases. And so based off of those two things, we can figure out where you are looking at a point in time, and we actually just track that through time to figure out where you are paying attention, because typically wherever you're paying attention is linked to where you're actually looking at that point in time.
So here, instead of using eye tracking to determine where people are looking, we're assuming that they can only see these markers that are specially designed based on attentional characteristics. We're assuming that if they click on these moving markers, that they're looking in that region of the interface.
Thanks, Tom and Roger. So in this study now, what would your independent and dependent variable be?
Okay, so in this study, it's a methodological issue that's being examined. And so we're comparing eye tracking as a measure of attention versus this new measure of acknowledging these events as the measure of attention. And that's phase one of the study. And then there's actually a follow-on phase, phase two, in which we look at how attention is measured in undergraduate participants versus trained operators that have experience working in the power industry, and see how their attention patterns differ from each other.
And technically, when you're looking at two different groups like that, so the undergraduate group versus the professional group, that's a quasi-experimental variable, because you're not really manipulating whether they're trained or untrained. It's the same when you look at gender, for instance, and you compare male to females. You can't control their gender, so it's a quasi-experimental variable.
So is attention your dependent variable?
Okay, so yeah, attention is a dependent variable in this study, but it isn't the only one in this particular case.
Yes, we're also looking at primary task performance, which is how well they actually control the nuclear power plant in the microworld. And we can assess that by looking at how much power they're producing, how efficiently they're producing it, how well they're able to deal with faults, and other measures that relate to how the plant is performing.
So how are you going to analyze that?
Okay, so the analysis will entail correlating this new measure of attention with a gold standard, which is eye tracking that we use to measure attention. And so we'd like to see that they correlate well with each other. So wherever you're looking at a point in time should correspond with where you're acknowledging these markers. And then after that, we also want to look at how attention relates to performance on the process control task. And so we would correlate where individuals are looking at the interface and getting information from in order to get good performance. So you correlate kind of attention allocation performance. And then as part of that as well, you can also look at how novice users like students, how their attention patterns compare against experienced operators, and how those differ.
So Tom, this really sounds like a comparison of internal and external validity. The first study really seems about internal validity, and the second study about external validity.
Yeah, that's right, because both types are important. And we want Tom's new measure to be used in the real world by practitioners, by human factors professionals. And to do that, they need to have confidence that if they use this measure that's easier, that it tells them the same thing as the existing measure, the gold standard, and also that what we found with our student operators will generalize to real professional operators.
Okay, thanks Tom and Roger. I think that'll be really helpful for the students. Now, I've asked a few of my friends in the past, and I'm going to ask you two as well. Simple question, what makes good research?
Okay, so good research is made by first coming up with a question that's clearly testable and focused, and then controlling the conditions that you're examining it under in order to come up with clear results that you can hopefully apply to something.
Yeah, I think I would agree with that. So good research needs to be based on science. It needs to be testable, it needs to be empirical, it needs to be rational, it should be parsimonious, etc. But then I think what Tom's getting at is that research should also provide value. So thinking about the value that it provides is also important.
Okay, and I would be remiss if I didn't actually introduce Casey Covesti, who's been playing our cameraman. He's also a researcher at Idaho National Lab. Casey, what do you say? What makes good research?
Well, I would say good research is a very targeted question that basically is based off of previous literature and something that can also be replicable for future.
Thanks, Casey.